Okay, ready for part two? Hey, Izzy, Isabella, wake up. Wait, your eyes are drooping again. Wake up. Are you blushing? Have fun with this part. So this is a tooth kind of thing, right? Here they tell you a story, right? And they got several parts to this story. They say within this plaque that covers your teeth, right? The outer layers have high levels of oxygen. The layers closest to the tooth contain low levels of oxygen. And this is where we have some acidity can break down enamel and cause cavities. And then they tell you that this kind of bacteria, the mutans kind, right, thrive in that innermost level that they told you is acidic and low levels of oxygen. Okay? And then another type of bacteria, the sanguineous kind, compete with these guys, but they don't do so well in acidic environments, implying that not many of them live in that lower level where the tooth decay is happening. Okay, so here's again our breakdown of our question. Identify the pathway that this one uses for metabolizing sugar. Where does it live? In a place where it's acidic, right? And where does it live also? In a place where there's low levels of oxygen. They want you to connect low levels of oxygen and acidity with fermentation anaerobic stuff, right? So now this is 2 points. And what this box is, well, there's 3 ways you can get those 2 points, but you have to make the right connection between what you put in the identification box and what you use in the description box. So if you said, oh, they live in anaerobic situations, so they do fermentation, they must do the lactic acid kind, and that acid is what's going to make this acidic, right? The low pH contributes to the low pH. Or you could simply in general say, well, they do anaerobic respiration because you said they live in low levels of oxygen, right? And anaerobic respiration produces acid. I don't remember what kind, but it's acid that low pH is all about. So bingo, bingo. Very non-specifically, you could get those same 2 points. Or you could say, well, the way they break down sugar is actually by glycolysis, right? And that produces pyruvic acid, which is an acid. There's the low pH, right? Ignoring the fact that that acid is going to get broken down by fermentation to this kind of acid, but good enough here. So now, predict how the population size of these two might change. This is a little bit more of an ecology question, but okay. Um, it's also in analyzing the data, the story we've given you, and being able to apply it, right? Normal toothbrushing, da 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 da, contains alkaline components. Oh, these guys did well in the acidity. So if you make it alkaline, I would predict that those guys are going to decrease. And if those other guys competed with them, and now you remove that competition and you make it in a place where they aren't being affected by that acidity like you said they do, unable to thrive in acidic environments, I would expect these guys to increase. And here's what you don't know when you have this question. Is this a 2-pointer or a 1-pointer? It doesn't matter. They told you to address this and that, so address them both. In this case, you had to address them both to get that 1 point. Ready for the next one? Did you connect the fact that you should like floss between those teeth, right? Haha. Now this one, I had to make this small, sorry. They gave you all the diagrams of glycolysis, Krebs cycle, and the link reaction in the electron transport chain and just asked you some questions about them. So describe the contribution that each, so you need to address all 3 of them, right? Um, each of the following in what? In ATP synthesis specifically. Okay, so how about the glucose and then the link reaction would be pyruvate oxidation? That's this one, right? How about that one? How does that contribute to ATP synthesis? Well, some ATP is made here. So this breakdown provides energy for the actual making of ATP, right? That's kind of the simplest one. Or it produces NADHs that are going to be used in the electron transport chain to make ATP like it shows here. There's the NADH, right? There's the ATPs being made somewhere around here, all right? Or it provides this stuff that can go into the Krebs cycle, right? There's that stuff. It goes here, and the Krebs cycle makes ATP. So you could have said either one of those three things, right? But it had to be talking about this glycolysis and link reaction. Either one of those three things would get you that 1 point that you could get for this box. Okay, now, how about the Krebs cycle? What could you say? Well, again, the Krebs cycle makes ATPs directly, but if you can see it, this diagram doesn't show that. And this is a little bit older question. They won't expect you to know that these GTPs are going to pass their energy on to ATPs. So they would probably have an ATP making step right here in front of you and say very simply, well, in the Krebs cycle, ATP is made, energy is released to make ATPs, right? Just like they did up here, okay? Just like they did up here, you can say, well, Krebs cycle produces these things which are used in the electron transport chain to make ATP. Or what these things carry are high energy electrons for use in the electron transport chain. Kind of saying the same thing, right? Or you can say that these things both provide the energy to pump protons against their concentration gradient in the electron transport chain, right? So you can say it without mentioning electron transport. They gave you 4 chances to get that 1 point, okay? And now the formation of this proton gradient, right, which has yeah, as I see it, it has no lollipop structure in here. So they kind of expect you to know that all this stuff is also going to be involved in ATP production. How? The flow of the protons through the thing that they didn't show you, membrane-bound ATP synthase, but they told you in the syllabus you need to know. Or very simply, this is very simple. The flow it provides, this proton gradient is a form of potential energy, provides energy for making ATP. Ready for the next? A little bit of math here, okay? 2 different math things. So they give you these numbers, right? They tell you that 1 ATP, 1 mole, excuse me, of ATP is worth that much energy, right? So how much energy is in 30 moles of ATP? 30 times 7.3, 219, right? Right? The efficiency of total ATP production from 1 mole of glucose that they told you as this. Basically, how much of this ends up in ATP, that's what the efficiency would be all about. So how much ended up in those 30 moles of ATP? 219, 219 out of a possible 686, right? That's a 6. 86, right? That gets you to either that in decimal form or that in percent form as a measure of efficiency, right? What happened to the other 69 or 8% of it? It was released as heat energy or increased entropy disorder. You could have said either one of those. Okay. This one you could have a lot of things. Pose a scientific question that connects what they asked you to know, that these little creatures and chloroplasts, mitochondria and chloroplasts, were prokaryotic cells, right, that became part of eukaryotic cells. Okay, so a valid question that connects the location of the Krebs cycle and the enzymes of the Krebs cycle would be something like this. Since the Krebs cycle occurs in the inside of a mitochondria, right? Does that suggest that mitochondria were once prokaryotes? That would be a question that relates to the evolution of eukaryotes and the location of the enzymes in the Krebs cycle. Make sure you pose a question. Don't make a statement if they ask you to pose a question. Okay, here's the next. Once again, a little math here. The question I flipped on that screen, sorry. The time difference was 2 minutes, right? From 2 minutes to 4, it's 2 minutes. And the change in the amount of whatever that was, now I've forgotten, is from where it started at 2 minutes to where it ended up at 4 minutes. That is an increase, right? So this is going to be positive. Remember that rates can be negative. So rates are always change over time, right? That's very simple, but they can be negative if that change was a decrease. In this case, it was not a decrease, it was an increase of 1.9 in 2 minutes, 0.95 per minute. That would be the rate. Happy Easter. Here's a little biology. These kind of mammals are the only kind that lay eggs, and they're not as cuddly as a bunny. This one probably is, but this one's not because it's kind of anteaterish. It's got those spiky things. Um, Hope you had a great holiday, and I will check with you next. As always, don't hesitate to ask questions, and okay, bye bye.